Okay, so far we have solved equations with variables on one side, and we have solved equations with variables on both sides. Now we're going to go over identities and contradictions. So please go ahead and write those definitions down. You should probably be on page 15 in your notebooks. So you're going to write that an equation with infinitely many solutions is called an identity, and an equation with no solutions is called a contradiction. And of course, we're going to go over a couple of examples. The first one is is 5 times x minus 6 equals 3x minus 18 plus 2x. We have variables on both sides, so we're going to use the distributive property and then we're going to simplify it. So 5 times x is 5x, 5 times negative 6 is negative 30, equals, we're going to combine these two like terms. 3x plus 2x is 5x minus 18. Now, of course, I want to have all the variables on one side, so I'm going to subtract 5x from both sides, and that's going to give me a negative 30 equals negative 18. Well, that doesn't even make sense, right? Because negative 30 is not the same as negative 18. Whenever you get something like this is what is called a contradiction. Contradiction. There is no solution, so its solution is an empty set. You can represent it like that. Now let's take a look at another example. Let's try now 3 times 2 minus 3x equals negative 7x minus 2 parentheses x minus 3. Again, distributive property on both sides, so it's going to be 6 minus 9x equals negative 7x minus 2x. Negative 2 times negative 3 is positive 6. Now we're going to combine like terms. The like terms are negative 7x and negative 2x. So that gives me negative 9x plus 6. Again, I want to have all the variables on one side, so I'm going to add 9x to both sides, and that's going to give me 6 equals 6. Now that is true, 6 equals 6, but my variable is gone. What that means is that the solution is all real numbers, and you can represent it by that weird R. This means all real numbers. It means that I can plug in whatever number I want to in here, and the equation will always be true, regardless of the value that I give to this. Stay tuned for the last video. It has the inequalities, and then we will be done with the lesson.